Okay, so what you should have seen, and hopefully it matched what you predicted, is that she wasn't able to just head due east. If she wanted to set a course due east, if she wanted to end up going due east overall, she needed to point her boat to the north and to the east. We need to point a little bit to the north to cancel out the fact that the current is going to wash her to the south, but she also needs to be going a little bit east so that once after canceling the current out, she's still moving to the east and eventually winds up going straight across the river. We'd like to figure out exactly what that angle is. So, we need to go some direction like this, but exactly what angle would that be? Also, something you might have observed in the video is that it took her a lot longer to get across the river in that case. And so from the perspective of Donnie and the ground, it looked like she was going a lot slower, and so we'd maybe like to figure out how fast does she look like she's going compared to the ground as well. And so if we set that up as a problem, we want to know what heading does Princess Ducky need? So that's what angle does she need to point her tank at to set a course due east. So she actually goes due east relative to the ground. If the river's current is 3 meters per second to the south, and the tank moves 4 meters per second relative to the water. So that was our primary question. What angle does she need to point her boat at? And then the follow-up is, since we noticed that it looked like she was going slower, how fast will she appear to move from the ground? One thing that a lot of people guess is that we can just take and flip this triangle, and that it's going to be 36.9 degrees, but north of east instead of south of east. And it turns out that's not true. So if your intuition was, oh, it's got to be the same angle, it turns out it's not. And so what I'd like you to do is first, you're not going to solve the entire problem right away, but just set up the given information. So just like before, we sort of wrote down all of our given information, and we also wrote down the equation to show how they're going to go together. Just do that part. Write down the given information, or write down the equation, and then I'll check back with you before we actually go on to the diagram. So go ahead and pause the video, try to set that given information up, and then unpause the video. Okay, so we've got the Princess Ducky, P. We've got the water or the river. I'm going to use, I guess I used R last time, so I'll use R again. We could use either one, whatever we want. And the ground. And so we've got some different velocities that we care about. We've got the velocity of Princess Ducky compared to the river, the velocity of the river compared to the ground, and the velocity of Princess Ducky compared to the ground. And we know the way these go together, because the subscripts are still the same, is still going to be the velocity of Princess Ducky relative to the river plus the velocity of the river compared to the ground is going to give us the velocity of Princess Ducky compared to the ground. What is different is the information. The river is still flowing at 3 meters per second to the south, so that doesn't change. This is still 3 meters per second to the south. We want to know what heading Princess Ducky needs. And remember, her heading is the direction she's pointing, which is the direction she's going to be moving relative to the river. And we know that the course she wants is due east. The other thing we know is that her tank moves at 4 meters per second relative to the water. So that's going to be Princess Ducky compared to the river, because Princess Ducky's on the tank and the river is what is made out of the water. And so this is 4 meters per second. And the last thing we want to know is how fast is she going to move from the perspective of the ground. And so we have an issue where we have one complete vector and incomplete information about our two other vectors. We know what VRG has to look like, so we know what this one looks like. We know the magnitude of this one, but not the direction, and we know the direction of this one, but not the magnitude. So what I would like you to try to do is set up a tip-to-tail diagram that follows this equation, but also agrees with all of this information. Go ahead and pause the video, unpause it when you think you have your diagram.